Welcome all to today's Passive House Alberta Building Better in Alberta webinar series, sponsored by the Alberta Eco Trust. My name is Frank Crawford, and I am the Education Committee Lead for Passive House Alberta. Today, we'll be hearing from James Bererton, the CEO of ETA Energy Solutions and the CIO of Thermostor Solutions, about his eco-positive home. First, I would like to thank Alberta Eco Trust for their ongoing support, as it is very helpful in allowing Passive House Alberta to continue our work. As always, place your questions in the chat box and I will ask them at the end, or you are free to unmute and ask them yourself. So now with that, please take it away, James.
All right, thanks. I went one slide too quick there. Yeah, James Bererton, as introduced, this is our eco-positive home project. It's a demonstration project there's actually a number of experiments. I think I counted 22 on this project, but the intent was to design a home that was factory built, that was low carbon and net positive on the energy. It actually produces 3 times the energy it will consume, and the extra twofold go towards charging 2 electric vehicles for 15,000 kilometers a year. And so we'll go through the kind of life cycle of this build. This picture is very recent, about 15 minutes ago. So you get an idea of the state. We're getting close, at least on the outside, and then the inside is still a little bit more to come. So we'll walk through the different approaches. We go through construction, the water conservation measures, source energy is the big deal in this project. HVAC solutions, there's a lot of different HVAC solutions, as well as material selection, which is really important for the carbon assessment, especially embodied carbon. So on the foundation side, we targeted no concrete at all. That was a big trade-off in terms of carbon. We have a recycled rubber mat solution there in the foundation. There's no basement. We use energy piles, which is structural screw piles converted to energy piles. And then you see right there in the garage floor, the EcoFlex recycled rubber mat is just a slab on grade. For the walls, we tried to use a lot of wood products, and also with the insulation, that's where we really gain on the carbon side, on the biogenic carbon reduction. So there's hemp panel insulation, and there's sheep's wool interior bat insulation. We used a Shosugi bond on a quarter of the outside, and then for a low cost, resilient, we spent some of our carbon dollars on armor side metal siding. There will be truss core on the interior of the garage, but drywall for the interior of the home, pretty standard that way. We went with light zone windows, which we have 2 different grades of light zone windows, and we have some very large doors that actually use light zone IGUs for their center of glass. And it's metal clad wood frames. So basically trying to use materials that are standard materials as much as possible, and that have a low carbon footprint. And you can see in the bottom right picture there, that's the structural piles just before we landed the modules. Trying to get to the next one there. If you're not familiar with Light Zone, this is, in my opinion, one of the best, highest performance windows on the planet, and it's produced right in Edmonton, Alberta. We have the 6-pane version that's shown here, as well as a 4-pane version. So experimented with both for cost versus performance comparison. So the modules are split into 2 levels. There's an upper suite and a lower suite. They're essentially the same square footage, just laid out slightly differently, but 2 bedroom, 2 bath. And the upper module uses the 4-pane version, and the lower module uses the 6-pane. And I should say panes, or using that term loosely. There's only 2 panes of glass, but it's 4 interior plastic films, and that's how you get to the 6-pane. This is R17.5 center glass for the 6-pane, and R11.5 for the 4-pane solution. And here's our water measures. We focused on recirculating water, trying to reuse our gray water. So one of our showers has the rain stick shower invented in Kelowna, and that's 80% recycled water and energy right at the shower head itself. They're working on one that does the whole bathroom, and as are we, because we feel the cost needs to come down and we need to do more of the gray water at once. This is a really good solution. It's an approved solution right now in BC and Ontario and other places. Sorry, the rain stick is approved elsewhere, like even in Alberta. So it's got full certification. There's only about 3 showers in the world that do what the rain stick can do. So it's a couple Norwegian and Danish versions that also do this. We have gray water pipes separately throughout the building, so it can come into a gray water treatment plant where we're looking at what's it called, hydroflow. I'm just forgetting the name, but it was too expensive to implement on this scale. It might be for a multi-unit residential complex would be better, like even a sixplex, then it would make sense. But for our purposes, it was just too much, too far. But we would consider building our own in the future. It's pretty straightforward. It's carbon filter, UV filtration, and treatment in the tank, and then you can return it to for toilet flush. It would be permissible, and so we have for every toilet we have separate lines ready to receive that. Unfortunately, we also experimented with bidet toilets that only have one water supply, and you can't use recycled gray water for a hygienic purpose. In the future, we'll look at zip grow towers on the rooftop. We'll look at hydroponics, aquaponics mixed with the hydroponics. And then ultimately, we'd like to see black water treatment through a bioswale or other black water treatment solution for water reduction. But already we're at more than 40% water reduction in the home. For source energy, we looked at solar, but we use a different kind of solar. We use a PV thermal collector. The one we selected was from France. It's dual sun. We'll get into that, I think, a bit further. We have electric vehicles, which we intend to install a bidirectional charger, which means we can charge our house batteries from the electric vehicle. We can run the house off the electric vehicle, and that makes this much more independent and grid resilient. It also allows us to do some peak shaving potential, and that's one of the things we want to research with this project. Thermal storage, we have a number of different thermal storage elements. We have a large tank, it's about 400 gallons. And that one we will be doing experiments with our own macro encapsulated phase change material. We have energy piles, so 35 of the 36 piles we are capable to circulate within the pile. We did have some pile failures during construction, but we'll get into that during question period. And then we have phase change materials encapsulated inside the energy piles. And we have 8 different experimental phase change material solutions in there. And we're also doing continued phase change material research. We have one pile we can access and swap out the phase change material inside the pile and then circulate it and measure its performance in cycles. And all of this is intelligently controlled and minimizes our grid draw. Heating and ventilation, we have full hydronic systems. So both the radiant floors in the bathrooms and the fan convectors are hydronic. And that gives us individual room control. We have cooling in all the living spaces and heating only in the bathrooms. And it says they're non-condensing, but actually we do have condensing fan convectors now. The heat recovery ventilator is actually an energy recovery ventilator. We just wanted to experiment with that. We don't need that in the Calgary, Okotoks area climate, but we wanted to ensure that we could demonstrate it. We have everything on demand control. So we have all the air quality sensors, indoor air quality sensors sensing VOCs when you're cooking, particulates from smoke and forest fires, humidity and CO2 are demand controlled. So whenever the ERV, HRV is running, it's running just until it meets the set points that we set for good indoor air quality and ensure we don't have humidity buildup which could be a problem for a very tight building. 80% sensible recovery, that's when it's at its maximum efficiency. Obviously in the wintertime, it'll do cycles and not be quite as good as that. But we have a really interesting control system on that. So we even shut off the bathrooms when we're trying to purge the kitchen living area. And then we turn the bathrooms on full when we have a motion sensor in the bathroom. So it's very much demand controlled even on those other use cases. We have a specially designed heat pump. You can see that in the bottom left there. It's a dual water air source. So that was custom modified in the factory. And then we can use the solar to inject directly into the heat pump's refrigerant cycle and improve the performance of that. We're just now in the processes of commissioning that unit in its dual mode. And that also allows us to inject and extract heat from our other energy storages. So this is what the central plant looks like. This is also a very current picture. So on the left-hand side, you see all the electrical equipment. In the corner, you'll see a solar inverter that does all the management of our energy sources and how to send energy to the grid or to the batteries. You see those two little white boxes there below the gray electrical panels. That's our house batteries, two 16 kilowatt hour house batteries. You can see the distribution there, the orange and green on the wall. That goes to all the fan convectors and radiant floor, controls all that individually. And eventually on the right-hand side, you'll see all the pumps will be located for distribution and heat transfer to and from the large tank that'll be right in front of those black plumbing pipes in the middle of the back of the garage there. And you can see, I don't know if you can see my mouse or not, but right beside that blue potable water tank, there is a white phase change material tank. That is from Sunamp. That's a phase change material tank that changes state at 58 degrees Celsius. And it also has a backup electric resistive in it, which allows us to have backup for all our heating if we ever needed it. But we've got so many heat sources here, we're not really worried about it. So that's what the mechanical plant looks like. And the intent here, you can see the complexity, but the intent is that we've actually scaled down a district city scale logic and controls and miniaturized it for residential application. But with this system, we can test all the modes, all the controls as if it were a city scale microgrid. This is our dual water air source heat pump selection. That's the in the yellow box. You can see some of the performance there. This works down to minus 25 quite readily. Uses R32 as the refrigerant. At the time when we were ordering this and building it, propane R290 was not yet considered legal in Canada, and now there's now a an interpretation ruling on the current code that would consider outdoor R290 heat pumps to be viable, and they would be even better performing than this heat pump. Um, Here's our insulation materials. You can see the sheep's wool bat. We were very impressed with the sheep's wool bat. It's an excellent material to work with. It's a little bit hard to cut, so you want to make sure you have your stud spacing right for the bat insulation. But aside from that, you could touch it with your bare hands. You could even sleep on it. It's just a great resilient insulation. We've had some of it out getting rained on, and it self dries, fully restored, doesn't lose its, a lot of insulation when it gets wet, it compacts down and loses its insulation value. Not so with sheep's wool bat insulation. It is a slight premium, like 15% more than rock wool, but well worth it in my opinion. We used hemp panel outsulation. There's 2 inches of continuous exterior outsulation throughout the whole wall system. And then, of course, you see the wall construction is just simple stick frame with wooden beams. So we've got some PSL beams there that support this, allows us to build our modular construction and as much wood as we could put into it, even wood siding. There you go. And the EcoFlex mats, which we've mentioned already. So we did spend some money on some high carbon materials. The folded wall is a nice feature at the front. The armor side material was a really low cost, high resiliency material. So it's very resistant to hail, long life, 25 to 30 year. We did the trade-off with the screw piles versus the concrete foundations, and we're seeing a very significant reduction in the carbon for that carbon footprint compared to concrete with a basement. And as you know, concrete is about 40% of the house's total carbon footprint. So to be able to reduce that big player, we want to find solutions that make sense there and are easy to deploy. The metal siding, of course, that's going to add to our carbon footprint. We had steel studs only in the bottom 4 foot because we've designed the bottom 4 foot perimeter of the entire project to be flood proof. So all the materials in that, we didn't use the hemp outsulation. We switched to rock wool outsulation for that. And we have steel studs, we have the sheep's wool. So every component of that 4 foot is completely flood proof. And that was kind of based on the high river flood that occurred here in Alberta in 2013, and just seeing those homes being utterly destroyed. Even the first stories were almost unremediatable. And so we wanted to show a design that could work even in a floodplain like that. Now, mechanical equipment does make up 40% of the home's carbon footprint. We have only the ventilation for a fresh air treatment. So our duct's maximum size is 4 inches. So that's all we needed to get the air to the different zones. It is a ducted system, but there's only like 3 rooms of supply and then 2 exhausts from the bathroom, and that's our full system, as well as the recovery from the main living space. And we use PEX piping throughout, except for some metal in the main mechanical plant. Lighting and automation, you can see here our engineer who worked on all the lighting and home automation. This is all done with Home Assistant platform. And the lighting, we have a number of COB lighting strips. The intent here, you see that one strip he's pointing at there, that goes all around the perimeter. And we're going to program in the circadian rhythm so that it'll help you wake up in the morning, help you go to sleep at night, generates melatonin at night. And that'll all be pre-programmed in the home automation. And of course, we can also, because it is a COB strip, program it to react to music, and you have a party mode that you can control via the Home Assistant platform. It's all controlled via your phone or the app. We'll have a screen on each level to control that space, that suite, and then you can control it from your phone. And then we have wireless switches. So there's no hardwired switching at all in the entire project. It's all done through wireless switches that communicate over Zigbee. And it was a challenge because we were trying to do the kinetic switches, and they work by you push the button. The energy of you pushing the button is enough to send the signal, but we couldn't get those to work with our hubs, so we had to go with battery powered switches, which we don't like to have batteries as a limiting factor in our design. So that was one of the interesting things. And then we've got a very advanced control system that we will be rolling out eventually in just Raspberry Pi mode, which would make the controller be under $150, fully redundant. But presently, we're using an industry standard T-Box controller and a VT SCADA remote interface. So this is a video of the project getting laid into position. You can see it's modular. There's the first module being trucked in, and then they get craned into place. It's quite the interesting site because it's a 46,000-pound upper module. So that was really interesting. And then laying it down on those concrete piles, our pile contractor was excellent. What they do is they put the piles in and then they laser align the plates and weld them in at the last step. And that was really interesting. Their precision, I would say it was within 2 millimeters. It was not good. And even when we laid the modules down from the factory, they were also the tolerance. I think there was less than a 1/4 inch error, even between the doorways that join between 2 modules on the lower level. So that was pretty well done. You don't have to be that precise. You can adjust, but it was nice to have it very precise there. So that allowed us to build these 3 modules. There's a single bedroom module, the lower module with a bedroom and a kitchen, living area, and the upper module has the bedroom, bathroom. It's the full module is a full suite, 53 feet long, 19 feet wide, 46,000 pounds, and that basically is a complete living space that you could take to a northern community, drop it in place, and you would have all the energy features you need, and all the high performance and quality control that you can get in a factory. I'm just going to skip ahead in this video. Maybe any other, I think there's the big module coming into play there. Skip the talking parts. You can see the talking video on my LinkedIn.
Oh, did we just lose James? Did he freeze? Hopefully he comes back in a second. Well, hopefully James will come back in a sec. Because yeah, I got so many questions now. Give me a sec, see if I can try to get him back.
Lost the internet there.
Yeah, we can hear you, James. So it,
Okay. Do you want me to share again in case there's any questions on the?
yeah, share again, but maybe skip the video that might have been the death nail.
I don't know what it was. Yeah, I think it was just I lost internet because I saw the internet go out. So
Oh, okay.
anyway, I'm back. That was the end actually. So did we need to do the video again? I don't think so.
No, we don't need the video. Yeah, sit your presenter mode again, and I'll start with the questions because I've got a bunch and there's a bunch as well.
Okay,
Um,
go ahead.
yeah. Uh, who did you use an existing prefabrication company to do the modules? Did you build them yourself? Who did the modules?
We used 42 Tech is a modular factory in Calgary. Basically we leased their space. We used their framing crews, but we managed all the trades inside the factory, and so effectively doing it ourselves as the general contractor. And in the process, we had to become a registered builder and take over the new home warranty. So now ETA Energy Solutions is a licensed builder in Alberta. So sometimes you have to go further than you think, but we could have used the full services, but it would have been expensive to use the factory build. One of our lessons learned was if you're doing a prototype, it would be better to prototype the building separate from the factory build component. If you do your prototyping with in situ traditional building, we could have done that on the piles and still been ready to trial the beta version in the factory. That would have been much more cost effective and efficient for prototyping. We feel the factory build should be done with already proven modules, very modular design, and just repeat, repeat, repeat. And also to have a larger factory where you'd have 5 or 10 going on at the same time. And then you can get the labor savings that you see in California with 15 to 20% construction savings.
Yeah, yeah. So yeah. Um, so you're doing a lot of things here. I guess could you maybe quickly as some of the various different technologies you're doing, are any of them actually ready for mass production and scaling, or are most of them just at the testing and seeing if it works phase?
No, there's definitely some that we would say are ready for mass deployment. We would still optimize them. That's part of why we're running them inside this home. But for example, the heat pump solution with energy storage. That's ready to roll out. We have multiple energy storages, as you saw in the home. So we can store in the ground below, we can store in a large phase change material tank, we could store in a smaller, shorter term phase change material tank. And the reason for the storage and the heat pump combination is air source heat pumps don't like to operate below -15, and they don't operate at all below -25, -30. And that's a big drawback of air source versus ground source heat pumps. Ground source heat pumps are too expensive to deploy a field that can service a large load. But when you combine the two together, either with ground source or a short-term storage, then you can get through those coldest peaks of winter, and that solution is ready to roll out. In fact, we're looking at 2 retrofit projects where we're going to maintain the 100 amp service to Calgary homes and do exactly that. We're going to have a short-term or what we call the medium-term storage tank. Maybe it's 400 gallons, that kind of range tank, and then the dual water air source heat pump. And we don't even have to tie that to the solar PV thermal. The PV thermal is also completely proven, 20-year track record. This is the 4th generation. It's not a new technology, but pairing them, putting these together, that's what's new, but it's easy because each piece of the puzzle is proven. So we can do those things. Other things like the lighting and automation, that I would say needs some more work. We're still working on the lighting design to make that fully automated and reduce wiring costs, not increase them. But we did really like, and we now have solved many of the hurdles for the lighting solution. So we can do 24-volt DC light bulbs that we can run from controllers through the Zigbee, through the Home Assistant. And we also have the COB strips that we can do. So if we were to do it again, we would just change the way we distribute the lighting, and that would be deployable. So we're very happy with that. And the fan convectors, during the course of this project alone, we ran into a cost barrier on fan convectors. So a fan convector is basically a coil with a blower at the bottom. That's it. It's like a radiator, very standard piece of equipment. But in Canada, the certified versions are $1,000 to $1,500 for a 1-ton or half-ton unit. We were able to, even during the build process of this project, go out to China, get one certified at 24-volt DC, and we can do full control on a 4-wire system. It was way easier to connect. We have one in the house already in the stairwell, and that's essentially a proven product ready to deploy and allows you to do a high efficiency hydronic, low temperature heating network and really easy to wire up on 24-volt DC, which allows us to integrate with solar systems. So those are some of the technologies. Energy piles, still some experimentation to go there. We had a lot of failures on the welding. We have some procedures now developed from lessons learned where we would test at each step of the way so we can ensure we can repair the welding before we build around it, things like that. But they're pretty standard things that we could have done if we weren't in quite the rush that we were to get finished. But
Okay.
let's see if there's some more questions.
Yeah. So I guess, so the sheep wool. I have a
Oh, great.
question. Was the reason you went sheep wool versus like dense pack cellulose, and because they have similar properties, and how does sheep wool deal with rodents and bugs living in it? Because dense pack has the borate that stops them.
Yeah, so sheep's wool is naturally mold resistant. I'm not sure if that's resistant to bugs or not. And we chose that. So we have bat insulation. In the first versions of the home, we'd actually designed with a double wall stud wall system. So we were going to go with the high performance wall, do an R40 wall system. But when we did the energy modeling, we went away from that because effectively it would have cost us about 75,000 in extra structure, material, labor, et cetera. We would have blown in cellulose insulation in between the wall cavities. We would have still had to have one cavity filled with bats. But when we did the energy analysis, 75,000 to build it, we would have lost 75,000 in real estate because we're coming out a factory door that's exactly, you can't be bigger than 19 and a half feet wide. So when you add the insulation, you lose a foot of interior space. And so that was $75,000 in real estate value, or dollars per square foot value. So by going with the thinner wall, we actually went all the way down to 2x4 stud wall, I'll tell you why you shouldn't do that, but that was the cost savings measure. But that meant we spent $500 more on energy. That's it. It was less than one full PV panel. With our high performance energy system, it made no sense to go from R40 even to R20. There was no benefit to go, sorry, the other way around. If you went R20 to R40, $500. And the cost was monstrous on the envelope and
Yeah.
double monstrous on the real estate value. So that's why we went with a thinner wall. That's why we went away from cellulose. We were going to have cellulose in the ceiling, but when we did the woofy calculation, we were condensing in the ceiling with the cellulose, so we couldn't even put cellulose in the ceiling. We'd like to redesign. This is a flat roof design. If you designed with a traditional attic roof system or a shed roof, then we could have done in the attic the cellulose, and we would have done that. Cellulose was always part of the plan. It's a great low cost material, but didn't work out for us in this particular project.
Okay. Well, since you started, why don't we go a bit more down the optimization of the walls? So 2x4 plus hemp or temperature on the exterior. So like R20 walls.
R20.5, yeah. With the
Okay.
D rating for the studs, we got to R20.5 with our sheeps, because the sheep's wool's R15. So it's slightly better in the 3.5 inch space than you would
Oh,
get out of other bat insulation. So yeah, it was quite far down from what we initially targeted, but you focus where you should. So the windows were upgraded. They were the highest end, and the walls were they were below code, right? The code's R26. So, but because the windows were
17.
such high performance, pardon?
Our code right now in Calgary is R17. So you're still above code.
Or
In B,
17 for
yeah, in
um
BC we're R22. Calgary, Alberta's still stuck at tier 1, which is R17. Whatever.
R17. Well, okay. National Building Code, Alberta Edition 2023. I thought it was higher, but anyway, that neither here nor
Yeah.
there. The point is
Yeah.
we're slightly above that code. We were trying to hit R26 as the limit, but even then we didn't hit the R20. R26 is one that we evaluated. So 2x6 wall with outsulation, getting a true R26. That would have been actually a better design, because what we ran into, this is one of the lessons learned, with the 2x4 wall, you can't run your kitchen plumbing in the wall. However, our plumbers are used to 2x6, so they ran the vent lines right through the 2x4 wall with a 2.5 inch hole saw for 20 feet, leaving about, quarter inch
Not
of
much
wood
not
in
much
our
structure left.
structure. Yeah, not much structure left. So we had to redo that entire exterior wall. We had to add an interior plumbing wall for them to do the kitchen. So it was a minor disaster. But 2x6 walls would have been great. And the extra insulation, yeah, it wouldn't have been worth it. And it wouldn't have been worth the real estate value, but I would still do it to avoid the constructability issues of a 2x4 wall. Our trades now are not used to 2x4 walls. It's not the 80s. I don't know. Maybe that's just an opinion. Maybe there's some trades with the right site instructions that would manage it, or design your plumbing walls from the outset so you don't have that. But there were other issues with utilities, running utilities. And if you look at 475 architecture, they have a wall system where you've got a utility wall on the interior, and then you have the exterior, and you change where your air barrier is. I think that might be there's a reason they have that wall system. Let's put it that way.
Yeah. Yeah, it's you're it's always the question on, do you go more high performance mechanicals, less performance wall versus more wall and
I
simpler
think that
mechanicals.
balance needs to change, because the level of performance we're getting out of our mechanicals is so much better. Like COPs over 6 with our mechanicals. So when you have that situation, and the cost of the mechanical is much lower than the cost of envelope upgrades. So I mean, not in the case of the windows. The windows were very expensive. I think you have to find that balance point where one more dollar spent on the mechanical system is equivalent to one more dollar spent on the envelope. When you find that solution, you'll have the right application.
Yeah. Okay. So, I had this question that came in again. Those light zone windows, they've been around. Well, there's been versions with window films for a long time, and many of them failed because the films fail. So what is
Yeah.
your
Light
comfort with Has Light Zone figured out how to keep the
Yes,
films?
yeah. Light Zone has figured that out. So, and there's, and in my opinion, again, the only one who has. So the other vendors of film-based windows don't have this solution. It's a patented solution. So all four sides have tensioners in the Light Zone IGU unit. So the tensioners keep that film taut in all different directions, and they adjust automatically to the temperature so that when it's hot, it's the film will expand and it increases the tension and vice versa when it's cold. So that is what allows them to have a 30-year warranty. And it's not like the prior versions. So the president of Lightzone was in a different corporation with a different window design, and that window had failures, but created his own company, his own version, completely different design of film-based window. And that's been going since 2012. And they're just now starting to expand and get more well known. But yeah, I would stand behind it. There was one window we had a problem with in that from the factory, it wasn't set properly, and you could see little ripples about 3 inches in from the edge, but only one out of about 23 windows had an issue, and that one's it's just a warranty issue. We'll get that one replaced. So we're very happy with the IGUs. It's still tricky. Any window, any high performance window, it's tricky to get the installation right. Make sure you've got all the sealing there. Make sure your latching systems, all those work. That's always a challenge. But no, this the we my opinion, my personal opinion is the 4 pane solution. So 2 films and 2 panes of glass is the cost optimal solution. And they also have a frameless solution, which I think would be more cost efficient than paying. When you pay for the frames, it's almost doubles the cost of your window when it's operable. It's maybe 50% more when it's a fixed window. But this frameless solution would drop that cost down. And when they get up to scale, they could be 30% less than they are right now for price. And that would be directly competitive or lower price than a triple pane competitor.
Yep. I guess since you've got the windows installed, have you noticed, because their visible light transmittance is fairly low. I think it was down to like 20, 30%. Does it still look like a window, or I guess when you go outside, does it seem a lot brighter out than when you're inside?
See here. I don't know. Yeah, you can't quite
It's
see
been
there
you got
in
your
the
you
camera
got your
because
blur on. You
the
got your blur
blur
on.
on. Okay. Let's see if I can fix that.
I guess what's your opinion? Do you notice the lower visible
No,
light
not at
transmission?
all. Not at all. And I wouldn't even call it lower light transmission. Now it's so bright. There you go. Yeah, it's like any normal window to me. And we even have, when you open the doors on the back deck, you can see the difference, right? The contrast, right? Because it's fresh daylight and then the lights on windows. As soon as you close them, you can't tell, right? You don't notice that you're losing the light. It actually, at that level, it's better. We've got a west-facing deck, and it's good to have a little bit less light coming in. But here, it's so bright, and these windows are quite large. It's no, not an issue at all with reduced visual light transmittance.
Okay. Do you want to talk a little bit about the phase change materials, how you may be using them in the thermopiles and maybe the other ready for mass adoption versions? And are they all just the salts, or what's the kind of the environmental
Yeah.
footprint of some of those phase change
Yeah,
materials?
so that's an excellent question. We are doing continuous research on phase change materials. We have two different main chemicals. Calcium chloride, hexa and tetrahydrate is one salt solution. Calcium nitrate is the other one. So they change states at different temperatures, and we want to match our state change temperature to our peak heating supply temperature. So we can charge just a little bit above our peak heating supply temperature, and then it'll change state, and it will allow us to deliver without using the heat pump when we discharge. So that's the key with phase change materials, that you want to only use the heat pump once, either to charge or discharge the phase change material. So we have two different salt hydrates, but we have 4 different formulae for each, because we've got nucleates that we have to research, and we've got other chemicals we add into the mixture so it gels and doesn't lose as it precipitates out. We don't want to have it at the bottom of the pile. So that is a challenge using salt hydrates. In the future, we'll look at some organic phase change materials that are homogeneous. So then you don't have to worry about anything precipitating out. It'll stay uniform in a vertical pile throughout the life. In our tank, we're going to go with horizontal macro encapsulated phase change material, which means we don't have to worry about this precipitation out and the failure to rehydrate when you're changing states. So there's a lot of research left to do on phase change materials. That said, the tank we have for our hot water is the P58 from Sunamp, who's been doing it for 15 years, well-proven technology. It'll cycle more times than we'll ever need, and there's no issue. So there's proven phase change material formula, but you pay a premium for that. We're trying to produce super low cost. So our phase change material, $2 a kilogram, and that creates a 4 liter solution. So it's very, very low cost. We're basically using fertilizer chemicals to do our phase change materials, so and road salt. So very low cost materials.
Excellent. All right, let's move on to water. And then we'll go to cladding. So water, unfortunately, is still pretty cheap in Alberta. So is there any cost payback to the rain
Oh,
stick and such, or
water's cheap in Alberta. That's interesting. When you think of the water, like you think of energy commodity price, electricity is also cheap in Alberta if you only count the electron price. But if you count the other costs, so water has a carbon footprint. We have to treat it. We have to process the wastewater in the sewage plant. And then we have a shortage of water, especially in southern Alberta. So Okotoks and many other communities south of here are limited on water, either for the wastewater treatment or for the actual draw from the river. So being able to produce a community that uses 40 to 60% less water per capita, that means we can build out better. We don't have as much of a toll on our own municipal infrastructures. And I think that's one of the tertiary impacts of our water consumption. It's not about water cost, it's about touching the planet lightly. And I think that's where we get the really big savings.
yeah?
I
Having
wanted
having said that, though, how do you justify? I think it's $5,000 or $6,000 for a rain stick.
Yeah, we don't.
Okay.
But Rainstick was actually close to 7,000. Is
Okay.
now down to 5,500 doing a bathroom, and we intend to produce our own version that'll do the whole bathroom for in the 2,500 to $3,000 range, and then it makes sense. And don't forget, it
Yeah.
also helps with maintaining the comfort in the shower. So you can have a 5 gallon per minute shower, use 1 gallon per minute. That's a big deal, right? So
Yeah.
you can have your cake and eat it too. So there's comfort, there's other reasons than just saving water that make sense to save water.
Yeah.
Um,
And how do you have to change the filters, and are they a big cost as well?
Yeah, well, I can't speak to that from direct experience yet. We're still in the commissioning phase of our rain stick shower. It's all connected up, but we haven't commissioned it, so we want to wait and follow the proper procedures on that. So I won't be able to speak directly to that. They say something like every 3 months or 2 months, depends how often you're using that shower. But I can't directly speak to that. Um, I
Okay.
just want to address some of the questions in the chat, so we're
Yeah, so we've got
jumping
the rain
right
stick.
past.
Why don't we do the bit more about the cladding, what material, and you
The cladding on I noticed a question about steel. It is steel, not aluminum. All the metal cladding is either 24 or 26. So one of them's a little bit thicker steel, so that makes it a higher quality. But we're really happy with it. I mean, $2 and I think 50 cents a square foot. That's very competitive, and we feel it's more resilient than fiber cement. And of course, fiber cement has a high carbon footprint, even higher than the steel because it's only 24 gauge steel, so it's thin, but it has that half-inch thickness to it. So it's quite good. What Yeah, what else can I talk about? On the cladding, the Shosugi bond, we had custom Shosugi bond that's charred wood siding. I think in hindsight, I probably would have gone with the direct from Japan, even though you have a shipping cost and carbon footprint with it. I think they would have done a better, higher quality job of the charring process. And in Japan, the charred wood siding has they have examples of it, the 500 years old with no maintenance, and that's what we were going for. Ours, we're noticing some flaking. There's a little bit of maintenance already, so we're a little bit disappointed in the homegrown version of it, but it also wasn't cheap. It was the most expensive siding choice.
Yeah,
So
I've heard that from another friend client that yeah, put Shushiban that was made in Calgary, and yeah, they 5 years later they had to start staining it because it wasn't quite done correctly. So yeah,
yeah, yeah,
spending the money I guess to get it correct.
yeah, yeah, and you wouldn't. In our case, we would have actually saved money to get it correct.
Okay.
Let's see.
Do you want to talk a little bit about gray water and black water and what's actually allowed right now by code?
By code. So, I mean, I know in Jasper, they installed water recovery for toilet flushing, but Jasper is a special case. It's in Alberta, but it's federally jurisdiction. So in Alberta, the code yet you have to get special permission, but I do understand there's been some hydro loops that have been installed in Alberta that are approved. So that's gray water recovery back to toilet flushing. Present under the code, technically, you can use it only for irrigation. You can't reuse it, but that's one of the things we wanted to demonstrate. So we will with our, because all of our gray water, our light gray water is segregated. So we can bring it in to a treatment plant of our design, and then we can have the testing done on that and say, look, Alberta Water Authority, we want to show you that you can use this for toilet flushing. It's UV treated in the tank. It's got the carbon filters. It's been done in California, Australia, BC, Ontario. Let's get this approved. But we can only do that when we have the data to show them that these systems work. Um,
Yeah. From Orland, I guess, sorry, maybe you want to type in the sushi bon charring. It's a sushi bon is a type of wood treatment where you burn the wood. Um,
Yeah, it's just charred wood, and typically you put tung oil on it as a post treatment. You don't have to. If you don't put the tung oil on, it'll kind of turn a light gray over time, and the tung oil just keeps it a nice black char look to it. So we have tung oil on ours, but it's not charred enough. It was charred out in Quebec actually. Our window and door manufacturer did the light zone windows frames and did the show Sukiban charring as well.
okay. Do you want to talk a little bit more about the solar thermal PV panels?
Sure. Yeah. The PV thermal, so it's a combination panel that has you got your PV cells on the front, and then you have a thermal collector on the back, just like a solar thermal flat plate. It actually has fine tubes that all the fluid goes through. It's a glycol solution goes through it, and then on the very bottom it has fins. I wish I had a better picture of it. Yeah, it's not that one. Is there one in here? No, I don't. Oh, there's, it's just all the people are in the way, so I can't. But you can see there, you can see the fin tubes behind the PV cells, and you can see the serpentine pipe going through it. That's the design of it. But what we're doing that makes it so excellent and high performance, we pair it with the heat pump. We lower the temperature to about 10 degrees Celsius year round. So whenever the air temperature is over 10 degrees Celsius, we're getting an extra 25 watts per degree difference from the ambient temperature per square meter. So at 10 degrees higher, so let's say it's 20 degrees outside, we're getting 250 watts per square meter or 500 watts per panel. And so our panel, like we have 15 panels on this house. So it's 30 square meters, 30 times 500, it's 15 kilowatts of thermal energy. What it means is in an annual basis, we produce about 1,450 kilowatt hours thermally per square meter. So this is a huge performance improvement. The best solar thermal collectors in Austria doing district heating with seasonal storage, they get about 600 kilowatt hours per square meter per year. So we're a little over 2 times what they're making. And it just means a very small array is enough to charge up whatever thermal storage we're using. Now they don't produce well when it's very cold out, but we're using seasonal storages, and that's one of my role as chief innovation officer at Thermostor Solutions is doing this on super high scale, city and large building scale. Brendan has a question. Go ahead.
Yep.
I think actually Kim put one in too
Oh,
about the
sorry.
reporting. I was saying that I think Kim also asked one about the reporting first. I guess
Okay.
if you have
Sure.
any, she said that, yeah, can we expect reporting
Yeah.
about all the features for
It'll
this
be
home in a couple of
even
years?
faster than that. So with our control system, we'll be putting in, we'll actually be publishing the data, maybe out of sync in time, just a week after live data. And you'll be able to get all these reports. We'll be doing 3 years worth of reporting that we will publish. We'll publish articles on separate systems with separate reports on them. But in terms of all the individual features in the home as a whole, we'll have that online available for everyone.
And
Cool.
are you putting those up on your own website or on SSRA because you have SSRA funding, or where, I guess, where should we look, or NBEX or other Alberta Eco Trust places? Where do we look?
Yeah, so yeah, we'll negotiate that as we go, but we'll certainly be happy to send a link for the live reporting up on SSRA and other sites. We're also funded by Natural Resources Canada, so to a larger extent, but and of course there was a significant investment on our behalf as well. So yeah, we'll make that as public as we can, and whoever wants to host it and have the link there, they're welcome to the generic, and then the articles will be publishing in journals and engineering journals.
Excellent. Anything else, Brendan?
Yeah. So my question was actually about the piles. So yeah, thanks for running me through through the presentation. Really cool to hear about all these other features. Um, so the piles, I understand they both have a geothermal loop, but then are structural too, right? So I guess my question
Correct.
would be, do they have to go, extremely far down compared to what other structural piles would be, or is it pretty comparable? Yeah, maybe you could talk a little bit about
We,
some of the
yeah,
cost
we were
optimization
limited.
there.
Yeah, well, we're actually physically limited by the ground, the soil conditions. These are 5.5 inch diameter piles. We could have done this with 3.5 inch diameter piles as well, but we in the design that we went with the piling engineer is a 5.5 inch diameter pile. So it's quite a hefty pile. It's more than we needed, probably double what we needed. But it only went down 12 feet because the soil is a hard clay, and that's all we could get. So it torqued out their piling and machine at the 12 foot because it's a screw pile. So that was a limit of the site, not a limit of the design. We'd normally like to go with a thinner pile and go deeper, but with 35 piles at 12 feet deep, we're roughly equivalent to 1.5 boreholes. But the volume of ground that we're thermally interacting with is 1,850 square feet. Sorry to jump between units, but 1,850 square feet times 12 square feet, it's massive. We could run this house for probably a month and a half in the coldest months of the year and get heat all from that footprint underneath. So we don't need that. We actually had quite a few failures at this point. We're going to get some of the welding redone on the cap. When they did the caps on top of the circular pile, that's when they position it precisely for the structural alignment. And those were done pretty quickly because they wanted to get it done and get ready for the modules to come. And therefore, there were some failures there and just needed a testing process to say, okay, test it now, and then just do a quick repair job, and it would have been fine. As it is now, we're testing at the end of it, and we're already buttoned up, and we don't want to break our membrane just to repair a couple piles on the perimeter. So yeah, we had some failures there, but no, we would like to go deeper from an energy perspective. And if you go smaller on the pile, you can, yeah, sorry, it's just reading the question. You can go, you get more energy transfer, you get more access to the ground. We did insulate all those perimeter piles are insulated. They're fully insulated. The ones on the interior will be wrapped with insulation, but it's okay because the top portion of the pile can leak into the crawl space and provide the heating for the crawl space. The crawl space and the garage are both heated, and they create basically a toque for our ground thermal store. We're hoping to get that ground up to 30 degrees. The rubber insulation will have, it's cheap wool insulation from the wall is what's wrapped around the piles on the perimeter. And then for the interior, we'll probably do the same. We have there was an error in shipping, and we got shipped 4 pallets of incorrect sheep's wool insulation. So we have 4 extra pallets of sheep's wool. So we will reuse that as much as we can on the interior piles that are not part of the wall.
Yeah. And the ground and the loops that you put into the piles and with the phase change material, that just is another thing that feeds into your air to water heat pump. So you basically you're
Yes.
just having
We
lots of
take,
different
yeah,
ways to feed different things into that air to water heat pump, which then either increases or lower the temperature, and then you spit it out somewhere else to either store it or use it. Is that kind of the intent?
yeah, that's true. Now I should qualify the pile. You've got a hollow pile, and we welded off the bottom, and we drop 1 pipe down the center, and we circulate down that pipe and up the annulus. So it's a coaxial pile. And then when we had an encapsulated phase change inside it, it was ABS pipes capped off at both ends, a little bit of air so it doesn't thermally expand and blow up. And that goes inside that liquid, and we shoot the 3/4 inch PEX pipe down beside it. So that's how we did this circulation inside the energy pile. So it's not actually a loop, closed loop in the pile. It's the pile itself is the circulating loop, let's say. It forms the basis for our circulation. Yeah, and someone asked about tours. So the project, we're hoping mid-July will get completion. That's where we're sitting at now. We were hoping that for mid-June and mid-May, but well, not mid-May. We didn't anticipate that, but we're very close. We're nearing the final electrical inspection. Plumbing is ready to go, and after that, we're ready for the final inspection. It'll be fully operational. I will have to move in personally to make sure all the systems work for the first 3 years, line it all out, and then after that it could be sold. But we want to run this for a long period of time and run all kinds of experiments. We want to invite people to run their experiments on our systems because it's fully instrumented. There's more instrumentation here than most surgical operating theaters. So it's going to be really interesting. I didn't touch very much on the HVAC system, which I probably should have spent a little bit more time on. Let me see if there. Can you guys see that? Oh, sorry. I can't see it because the people are in my way, but that little HVAC system is really one of the systems that we're trying to convert into a package solution. So you can see the HRV in the middle of the Atmo 200E there, but we've got 5 different damper valves there, so we can put it in recirculation mode, which we want to do if there's a forest fire, so we can run it through a MERV 13 filter or not through the MERV 13 filter. The reason we don't want to go through the MERV 13 all the time is it clogs up quickly, and you only need it for the really fine particles. So when we sense particulates going up, let's say it's a forest fire, we can run it through the MERV 13 and recirculate. So we're not trying to clear the whole atmosphere, we're just trying to clear the house. And then if there's a CO2 demand call, it'll switch to bring in the fresh air. When that's cleared, then it'll go back to filtering out the particles. So this system, it's got a UV filter on the right, so we can treat if you've got a sickness running through the house, you can go to UV mode and you can purify the air so that you're not transmitting to the other occupants. It's got currently a resistive heater there just to top it up when it's cold in winter. We'd originally intended a hydronic coil there, which we would do in future designs, but we also have taken this design off to our manufacturers in China and said, build us this in a modular, in 2 modules, and we will then create a product that you can have all of these features, but have a very simple installation, and you would have this much space taken up. It'll all be right in 2 modules, and you can pick and choose. Do you want MERV 13? Do you want HEPA filtration? Do you want the UV light? It'll be a menu of options, so that HVAC will be quite interesting as a productization.
Cool, very interesting. All right, I think we've made it through just about all the questions. Any kind of a last call for questions? And if not,
Scheduled tours. I just wanted to mention on
yeah.
scheduled tours, we are planning to have tours once a month for the first year at least, so that people can come out and see what's happening at the EcoPositive home and see what the progress has been on performance. And it's just southwest of Okotoks. It's about 3 minutes away from Okotoks, if that helps.
Excellent. Yes, lots and lots of interesting things that hopefully work out and get mass produced and cost effective and lots of good future
That's the
uses
intent.
for them. Yeah, any last calls for questions? All right, then if not, We are at 1 o'clock. So thank you all. Thank you, James, for your very interesting, very innovative project. And thank you all for attending. We're taking July and August off. We'll be back in September.
All right. Thanks, everyone. Thanks for spending your time. All right. Take care. Bye for now.
Have a good day.